Alright, again, we want to write this using sigma notation, find the sum if possible. Not going to be possible to find sum in this case because this is algebraic, meaning that we have that x in there. But maybe we can still write this using sigma notation. Well, it's certainly not arithmetic because if you look, we have our exponents on our x term increasing each time. And this is infinite, going on forever. But maybe it's geometric. So if it is, it's going to be easy to find the common ratio r because our first term is 1. So 1 times 2x is 2x. So that would be our ratio between our first two. 2x times 2x is 4x squared. 4x squared times 2x is 8x cubed. 8x cubed times 2x is 16x to the fourth. So our common ratio r is indeed 2x. So we can write this in sigma notation from n equals n equals 1 up to infinity of our first term, which is 1, times our common ratio, which is 2x, raised to the power of n minus 1. But be careful, you have to put it in parentheses, otherwise it would be like 2 times x to the power of n minus 1, and then your pattern would be 2 plus 2x plus 2x squared plus 2x cubed plus 2x to the fourth, etc., etc. You wouldn't get those increasing powers of 2. So you have to have it in parentheses. And no, we cannot find the actual infinite sum for this. I could tell you that since we know that to find, if we want this series to converge, I could tell you that 2x has to be less than 1, and I also know that 2x has to be greater than negative 1, because for this series to converge, our common ratio r has to be a value between positive and negative 1. And I could solve this equation. I could say x is less than 1/2, and I could say x is greater than negative 1/2. So then I can give myself a range of values that I know x has to be between if I want this series to converge. And I could write that as the absolute value of x is less than 1/2. Isn't math nice?